not cause so much emissions in producing the outputs from this technology. So to tell more about that, we have an excellent panel today. So we start with Alan Ransil, team lead from Filecoin Green. He will give a good introduction to this, and then we will have a discussion around the theme. Over to you, Alan.
Awesome. Thank you so much. And, yeah, thank you all for coming. So we're gonna talk in these two different pieces, right? So first, I'm gonna give sort of an overview, and then we're gonna have a panel on how to use Web3 to build the global carbon ledger. And this talk, I'm gonna start out by really sort of framing the problem as I see it, and where we can help by using Web3 native tools in order to do better carbon accounting across supply chains and across the global economy. And then I'm going to delve into a few of the particular principles and sets of technologies and design principles that we can really take from Web3 and apply to this problem in order to do a better job understanding what needs to be decarbonized and how we can do that. If we go to the next slide. Right, so I'm part of a group, Protocol Labs, that launched the Filecoin network. Filecoin is a distributed data storage network, and we exist to decarbonize that network. Data, really sort of this is key, right, for how we're approaching this problem, right? So this is from the UN website. Data is the lifeblood of decision making and the raw material for accountability, right? So this is the core of one of the things that we in Web3 can really contribute to decarbonization, is building better data sets to give us situational awareness on the ground, understanding what is happening and how we can actually, how we can best focus our efforts in order to decarbonize the global economy as quickly as possible, right? And so data is central to that project, because data is what guides all of our actions and lets us know, lets us really prioritize everything that we're doing, right? So if we go to the next. Right, so data being central to these efforts, here are examples of what that looks like, right? If you're a company and you're trying to implement supply chain emissions reductions, understanding where in your supply chain those emissions are coming from is central to that effort and is going to guide your strategy. If you're a government and you're trying to efficiently direct climate-related spending, same thing. You need to understand where in the economy your funds are going to be most efficiently spent in order to decarbonize your country. Or then, if you're a nonprofit, if you're an NGO, and you're trying to optimize what you do, you're trying to optimize your programs, and if you're trying to demonstrate your impact, having data that is accurate and trustworthy is central to that. If you go to the next slide. So the problem is that the way that we do emissions accounting now guarantees that the data we use is not going to be accurate or timely. I'm gonna go into exactly what that means and why the systems that we're using right now actually do guarantee this. Right, but that's a problem, because if data is central to how we are directing our resource spend in order to decarbonize the economy, we need that data to be good, and we need to rebuild the global carbon ledger in order to guarantee that it is, right? So why does the current system, using the greenhouse gas protocol in order to understand where emissions are, why does that guarantee that our data is going to be old before it can be used? So when you are doing an emissions accounting exercise for an individual organization, you need to run through, right, what first are my scope 1 emissions due to fuel? Next slide. What are my scope 2 emissions due to electricity? What are my scope 3 emissions due to my entire supply chain? I need to model all of that. I need to audit all of that data. And then I can go and, potentially I buy RECs or offsets or other financial products that allow me to lower my impact. And then I need to represent all of those emissions data in my downstream emissions intensities that I give to my own suppliers, right? So I have to run through this entire exercise, and generally, if I'm a company, I only do that once a year, right? And that's because this exercise is complex, it takes a lot of effort, you have to audit all of these numbers, and then you publish that data only at the end of this auditing exercise, right? And so, yeah, so I know what my emissions are. And so the pieces of that that are easy to account for, scope 1 emissions, scope 2 emissions, you know how much fuel you buy, you know how much electricity you consume because it's on a power bill, right? Those are relatively easy. However, the scope 3 emissions, right, so tracking emissions through your supply chain, are firstly much more difficult than scope 1 and 2 emissions, and 2, they're more important for most companies in most sectors than scope 1 and 2 emissions. Right, and so this just shows what the ratio is of our scope 3 emissions in all these different sectors to our overall emissions, or our direct emissions rather, and scope 3 is really important, right? So any system that is allowing us to do emissions accounting across the economy has to account for scope 3 emissions in a way that gives us accurate data and timely data. Right? The problem is if every company does this accounting exercise only once, we run into a lot of trouble. So company A runs through this entire accounting exercise. They do business quickly with company B, right? Company B is buying from them, making many transactions a year potentially. Company A only releases their emissions data once a year, right? So that information is going to be about a year old or several months old at least by the time it gets to company B, right? Then company B does the same thing, right? They use data from their supply chain, from company A, in order to determine the emissions intensity of their products, right? And so what happens then is when company C gets data that is based on company B, or from company B, that is based on data from company A, you have this problem, right? You have a lag of 1 year for every hop along a value chain. And that is what guarantees that data is not only going to be old by the time it is used, but it's also going to be inaccurate because the length of the supply chain is going to determine how old that data is. So you're going to be combining data with different amounts of time lag in this potentially complex way inside of your emissions accounting model, and it's not going to work out well, right? So when I say that it guarantees that data is going to be old and inaccurate before it's used, that's what I mean. And so today's systems guarantee, right, that emissions data will go old before it can be used. They also guarantee that scope 3 data for any sufficiently complex supply chain is going to be inaccurate, right? And so this is the problem as I see it. This is what, in building better tools in order to account for emissions across supply chains, using principles and technologies from Web3, this is central to what I think we can really do in order to help build the global carbon ledger, right? We do not have a full solution that I'm saying we can implement right away. What I'm saying is that in Web3, we work with a lot of tools that are applicable to this problem, and we should apply those tools to this problem with this frame in order to increase the velocity of this sort of information through the economy, right? So right now it takes months or years for information to travel through a supply chain about emissions. We should increase the speed of information flow to minutes, not months, right? And so there are 3 main principles that are going to allow us to do that. So firstly, we can make data open when it is feasible for us to do so, right? One of the reasons that it takes so long to do this entire emissions accounting exercise is that all of the proprietary data inside is locked in individual data silos. We can't just make all of that data public right away, but when we can, we should. We should default to open when it's feasible to do so. Secondly, we can decentralize our data, right? The entire framing of this problem is that, again, data is in these individual silos. Those silos are not meant to share information regularly with each other. And so we can decentralize the actual way that information is stored and allow people to build these global carbon ledgers together, not just independently. And the third is we can make data verifiable by using tools from Web3. So let's dive into sort of each of these individual principles. Firstly, open data. So we want to build open systems when possible. And I'm going to talk about an example of that from our work decarbonizing the Filecoin blockchain. So when you store data on Filecoin, the operator, the node in the Filecoin network, has to prove to you that they are continuing to store your data over time. And so there are 2 major components to that use electricity. First, there's what's called sealing, onboarding new data to the network. Then there's actually storing that data over time. And so what we're able to do is take that information from the Filecoin blockchain, which is open, it's publicly accessible, and we're able to develop a model allowing us to see for every individual node in the network what their energy use is, right? So we're able to take public information and turn that into a electricity use model, so which you can use to calculate scope 2 emissions. And from public information about IPs, we can see how that energy use is distributed throughout the world, right? What we're then able to do is take, so one, on the left there, that IP-based location information, two, in the middle here, these emissions data points, right, and combine them in order to come up with this map showing, like I said, how, not just overall what is the energy use from the Filecoin blockchain, but where in the world is that electricity use, right? Also, if you are interested in any of these slides, you can go to this URL up here, tinyurl.com, Web3 COP27. If you want to look at any of this, many of the things that are underlined here are links if you want to follow up on any of these references. So we're able to use open data that is updated regularly, right? The blockchain is updated every 30 seconds to get an idea of where the energy use is, how it's distributed, how it changes over time, right? And so then we're able to take that open data and combine it with renewable energy certificates that are also open. Right, so typically, if you want to decarbonize your scope 2 emissions, you often buy a bunch of RECs or IRECs or GOs or whatever the instrument is in your region, and you tell people that you bought them, but frequently you don't actually share those certificates publicly. So we're able to take this public information, combine it with public certificates, and use that to openly decarbonize the blockchain. Right, and so that's an example of taking open data and using that as the basis for your scope 2 accounting, which features into this. So next, the next principle here is decentralized data. What we really think of as one of the reasons that decentralization helps us to increase the speed of information flow in these networks is that the point of decentralization is to let people help you, right? Can you build systems that other people can contribute to so that you don't have to do it all yourself, right? And so an example of this is CO2.storage. So this is a storage utility for carbon offset data that uses what's called content addressing in order to store data such that it can be unambiguously referenced, and also the format of that data. So the data schema underlying that data also has a content address, right? And so the idea here is that each of these lines is a individual data schema corresponding to the metadata associated with a given type of carbon offset, right? So we would really like, when someone buys an offset, we'd really like to be able to get access to what the data is underlying that offset, describing what that product is, in a way that it can be unambiguously understood by a person or by a computer. And systems that currently exist, they take a lot of data and they sort of present it in a semi-structured way. Right, there may be data missing, there may be fields sort of swapped, right? What we're doing here is taking the precise data schema, so the format of that data, content addressing it. Content addressing is a tool from Web3 where you refer to data by the fingerprint of the data rather than by the location of that data on a server. So you're able to take the schema, the like type or format of that data, and unambiguously refer to it because it's content addressed, and then also content address the actual underlying data describing the offset, right? So there's two levels at which we are taking data and referring to it using content addressing. So why is that useful? Why does that help you decentralize these offset registries? So the answer to that is that if you content address both the schema or the type, the format of your data, and the underlying data, that allows you to do transformations on that data unambiguously, improve properties of those transformations. Right, so this gets a little bit mathy. We'll come back out of this in just a minute. But a few examples of transformations that you might want to do on data underlying carbon offsets are given two offsets from different registries, which one has longer durability, right? You'd really like a computer program just to be able to tell you that. Another is a given offset Corsia compliant, or does it comply to some other standard that you're interested in, right? A third is, how do individual offsets contribute to regional or national goals, right? So you'd really like to be able to take all of these offsets that are in different formats, potentially they're stored on different registries, and you'd like to be able to ladder them up to everything that's happening in a given region and understand how is this project contributing to, for example, NDCs. So The mechanism for doing this, so arrows here correspond to transformations or functions that are sourced from the community, right? And dots here just correspond to data formats. And so the idea is you can allow people to contribute transformations in a decentralized way, and then you can come in and you can validate those transformations. You can say, okay, the ones in green, we actually trust those are really good transformations. We didn't have to write them in a centralized way, we just had to validate them ourselves. Then what we can do is we can construct pipelines of transformations, allowing us to do more complicated transformations than we would be able to otherwise with less effort because we've crowdsourced all of this to begin with. Right, so using a centralized approach, you'd have to take every single thing you want to do to these offsets, and you'd have to validate each of those things. Right, but if you can break it down into pieces and allow anyone in the world who has the right context and knowledge to contribute pieces for you, you can decentralize that effort and increase the amount of interoperability between carbon offsets from different registries and different formats for different projects, right? So that's the goal of structuring data this way, right? Taking these Web3 based tools having to do with things like content addressing and applying them to carbon offset interoperability, right? So that was the second principle, let people help you. Third, can we verify data using new tools and technologies? Right, so this gets, previously I've talked about work we've already done. This is work that is being developed rapidly and is progressing extremely quickly, and I'm gonna talk a little bit about how we can apply this in the near future to problems in carbon accounting, right? So what are different types of verification? So one I already talked about, so content addressing, that allows you to verify that data hasn't been tampered with, right? So by addressing data based on the fingerprint of the data, not its location on the server, you're able to unambiguously reference what data you're talking about, right? So that's one type of verifiability. Another type of verifiability is that the data you're working with has a unique owner. Right, so you don't want just anyone who has access to this database to be able to just change things and not know who changed what. You actually, if users have their own keys and that's exposed to the users, then you're able to say, okay, this person is who contributed this, right? This bit of data. So that's another type of validation. Where did this data come from, or who did this data come from? Then the thing I was talking about that's a little bit more future-facing, right, is this thing called zero-knowledge proofs. So what zero-knowledge proofs allow you to do are validate useful properties while hiding other information that might be sensitive, right? So this is extremely relevant to the global carbon ledger because the data underlying emissions accounting is extremely sensitive to your business, right? So businesses aren't going to sign up for some sort of global carbon ledger if they actually have to just release all of their, their factory's information and just make that completely open, right? So how can we let them validate that their model is correct or their accounting is correct without forcing them to reveal all of that sensitive information? And that's where zero-knowledge proofs come in. So zero-knowledge proofs allow you to say, prove that I have the correct answer without revealing additional information. Or another thing that this cryptographic construct lets you do is, prove that information lies within given bounds without revealing the full answer, right? So cryptographically, an example of this would be like, could I prove to you that I'm above a certain age without telling you what my age is, right? And so this is an entire area of cryptography that has been advancing rapidly and is the basis for Filecoin, but we're starting to have other arenas where we can build zero-knowledge proofs and apply them to arbitrary use cases, right? And so this is an extremely exciting area for developing this sort of software that's going to enable this sort of information to flow through the economy much faster. So what I have in mind here is you take that entire emissions accounting model that an individual company does, you want them to be able to publicly commit to their model without revealing that underlying data, and you want anyone in the world to be able to check properties of that model. So examples of properties that they might want to check are that emissions in equal emissions out, right? So like they didn't just hide emissions somewhere. You'd really like them to be able to prove to people that they did that accounting correctly without actually revealing all of their underlying financial and operational data related to that carbon ledger. Right. Another example is that outputs are claimed by registered entities, right? You don't want them selling a bunch of, you don't want them transferring a bunch of carbon off of their ledger to some fake entity. So you'd want to be able to actually prove that everyone they're doing business with is a good actor in this system. Another example is you might want to be able to prove that statements made to, say, one of their customers agree with statements that they've made to everyone else, and be able to prove that to their customer without having to give that customer all of their other transaction data, right? So could you just prove, again, that this emissions accounting is done correctly, given pieces of information that they're sharing with other entities, right? And so that's what zero knowledge proofs allow you to do. They're extremely powerful, allowing you to reveal bits of information without giving away the entire picture, right? And so if we can build systems using zero knowledge proofs in order to allow information sharing, that's sort of the basis of how we should be able to rapidly increase the amount of information, the rate of information flow through the economy, and get much better situational awareness than we have right now. So can we use these sorts of tools in order to make this information flow through supply chains in minutes, not in months or years? And so those are the three principles, right? Can we make data open when it's possible? Can we decentralize data and allow people to help us? Can we crowdsource solutions to the entire world of people who have the knowledge and context to contribute? Can we verify data and use the right type of verification for the problem that we're trying to solve, right? Reveal the information that we need to reveal, validate the information that we need to validate, while keeping sensitive information still secret. And so the last sort of thought I wanted to end on is that it's really up to us. I think in a lot of cases when people take this sort of granular level of detail, they use that to push responsibility to the edges, right? It is easy to develop these sorts of tools and use them to say push all of the responsibility for emissions to the end user. That is one way these tools can be used. I think as we are building these systems, we should think of them as networks that allow us to reveal where the leverage points are and where the positions of power are in the network, where we can have the most impact if we decarbonize those nodes. Right, so we should think about this really as a global carbon accounting system that should allow us collectively to determine where are the leverage points in that system and apply pressure on those leverage points. And so I think by using that sort of philosophy to guide us, we should be able to build a carbon accounting system that allows us to, really, as I said, increase that velocity of information flow through the global economy, to make that information flow in minutes, not in months or years. And so thank you for listening to me sort of frame that conversation, right, and give you some thoughts about what the tools are when we say when we talk about working with data the way we work with data in Web3, right? Allowing me to frame sort of what that means and what I'm thinking about when we use those sorts of phrases, right? And so now we're going to have an amazing panel going into specific use cases and details about how we're able to apply these sorts of principles and these sorts of thinking to do carbon accounting better than we are able to with traditional tools. Thank you.
Okay, wonderful. Thank you, UNFCCC. Absolute delight to be here. Gaj, Masamba, the rest of the crew, as well as the supporting organizations, Open Earth. Thank you all for putting on and helping out with such an amazing event. I am absolutely delighted to be here. My name is Marc Johnson. I'm an environmental solutions architect for Filecoin Green, working closely with Alan and Ori and Caitlin and other colleagues here. And I am joined up here with a distinguished panel of guests. So maybe to kick us off, let's just start with a round of introductions. If you can start us off, and we'll go down the line.
My name is Orinayo, Ayodele, or just Ori, and I am the Filecoin Green Program Manager, and I help lead the grants and hackathons that is getting projects and protocols to build on Filecoin and to help mitigate climate change.
Great, thanks. Hi, my name is Hayley Moller. I'm part of the founding team and lead marketing at Thallo. I come with about 15 years of climate and sustainability experience, so I very much come to the Web3 space from the sustainability side, which is a kind of a trip and very exciting. But just a bit about Thallo, and I'm sure we'll go into this more later, but just to give you the context, we are a team of folks who come with sustainability expertise and also with Web3 expertise. And we're building an exchange for businesses and individuals to be able to buy, sell, trade, and retire high quality verified carbon credits. And so we do all of this on blockchain for a number of reasons that I'm sure we'll all get into in a moment, but essentially around transparency, traceability, efficiency, and also programmability, because the nice thing about blockchain technology is that you can tag this data that Alan was talking about and really have access to data in a really special way. So that's me. I'm looking forward to the panel.
Hello everyone, pleasure to be here. I'm David Thallo, co-founder of GainForest, which is a decentralized fund that leverages artificial intelligence to reward natural stewardship. And the funny thing about GainForest is it actually was founded back in COP23 at a hackathon in Bonn. So we are very, very much originating from here, from the COP environment, from the United Nations policy ideas. And what we are basically doing is we're trying to tokenize impact by leveraging multiple data sources, satellite-based, drone-based, field-based data collection of conservation projects to measure really, okay, how impactful is what their work is doing, and also to measure really the value of nature, because we believe that we cannot protect if we cannot measure anything. And we are really, really failing to capture nature's contribution to society and to our efforts on tackling climate change, and that's what we're basically trying to do. A full transparency layer built on Web3 with data that is analyzed and given open for all.
Hi everyone, a pleasure to be here. My name is Martin Weinstein. I'm the founder and executive director of the Open Earth Foundation. We're a open source, big picture, planetary scale innovation lab, and we incubate projects that we design and build in the intersection of emerging digital technologies, open source, and the needed collaborations between private, public sector, supranational sector to deliver that with a focus on digital public goods, data, and digital infrastructure as a mechanism to augment humans' capacity to deal with planetary resilience. We have programs on climate, on oceans, on cities, and energy, and we're a very proud partner of the UN climate change and a key partner of the Global Innovation Hub.
Wonderful. I told you, it's a very distinguished panel. I'm very excited for this. Before we get into some of the nitty-gritty as it relates to the tech underlying your platforms, I figured it may be useful just to kind of set the scene with respect to the environmental outlook, right? We're here at COP, we're hearing all the stories, everything like that. But let's talk a little bit about where we are, how did we get here, and really where are we going from that environmental outlook perspective. And Martine, I want to actually start with you and ask you, specifically, from your perspective, how can innovative technology or technological solutions be utilized and leveraged to help make measurable impact in this realm? And how can transparency be a real value proposition and driver to move countries, corporations, consumers towards a more sustainable future?
Absolutely, and super relevant in this COP, because right now we're here in the pavilion section, but often the heart of the COP is the negotiations, and the key part of what's being negotiated between now and next week is the global stocktake, which is at the heart of the Paris Agreement. 2015, we signed the Paris Agreement. All countries in a bottom-up approach determine their nationally determined contribution, and the heart is to constantly track where we're at to meeting those NDCs of countries, and then ratchet those ambitions. The global stocktake is the process for that. If we are to implement those NDCs, they're still not at the ambition that we need to meet a 1.5 degree target or a 2 degree target and efforts to 1.5, which is particularly the language of the Paris Agreement. What does that entail? At the heart of it, it entails accounting and accountability and the ability to put our data together that explains what we're doing in terms of our emissions, our mitigation, our finance, and our adaptation. So we are in an interesting paradox because the key part of the Paris Agreement now onwards is essentially to put this information together to drive finance and action on the ground that gets represented in the national inventories. The reality is, though, countries don't do that alone. Corporations put on their weight on also creating pledges that are aligned to 1.5 degree, tracking their emissions, that are verifiable, and they are obviously nested in cities, which are a fundamental part of the sources of consumption that drive a lot of those emissions, because most people today are moving towards cities, and those obviously sit in subnational governments. So one of the things that we've been working on is how do we blend both of those worlds together, the non-state actors and the state level aspects, so that we really come together of what we need, that everyone needs to be part of the Paris Agreement. Everyone needs to be able to track their emissions and mitigations into the inventory. Inventories are normally produced through sectorial data aggregation rather than individual site or corporate layer aggregation. Nested accounting for us is one of the key ways to that. The other paradox we have is that what Alan presented before is a fascinating vision, and it's the essence of what we're needing now. We need to build the digital highways to make sure that all the data, all the emissions data talks to each other, and we're able to have a fast reconciled process. Not a 5-year runway of global stock takes. We need to get to a real-time approach. It depends on where you're coming from. If you're coming from the finance side and you're pumping in billions of dollars into the economy, into projects, how are you seeing how those projects are actually visible in the inventories, right? For that, we need to have data and digital infrastructure. The problem is most people around COP don't understand that because it's esoteric and because data and digital infrastructure is essential but invisible, right? So we have a challenge. This is where we're at and where we have to be. I describe a bit of like the context where we're at COP, but as a community, our challenge is to educate, to explain that we've grown building infrastructure in cities and pipelines in grids. The future of the next years cannot happen if we don't build the digital public goods. And we have to figure out how to do that, how to finance that, because it also powers portfolios of our investment, how those companies work together, the totals more than sum of the parts, how all the projects within the Web3 and databases out there talk to each other. What we heard now, a lot of what we're working on is that. I think that's one of the key things that's our challenge ahead.
That was amazing. I mean, mic drop right there. That was perfect. You touched on so many key points I want to delve into further. But one of the things you just mentioned there at the end, the visibility, right, and how we can leverage digital technology and technological solutions to increase that visibility, that transparency, that verifiability of the state of these projects on the ground and how it translates up into these other nested accounting systems. David, I want to kick this to you because I know you and your team with GainForest spend a lot of time working with communities and individuals and organizations on the ground, assessing the state of those impact projects. So talk to us a little bit more about GainForest and what you all do.
So GainForest is basically coming from the idea that satellite data, first of all, is very useful for us to tackle the transparency problem of not having enough data to do a very rightful decision of, okay, should we conserve forest, should we pay carbon credits or not? But also it's not everything. So one of the problems we realized is in order to really have a full transparency ledger, we need to accommodate all different kind of data sources we can get, not just satellite data, but also drone-based data and especially data on the ground. Why is that? Because it's very, very important to understand that satellite data, for example, if you look at satellite data, the public data set is 10 meters per pixel, Sentinel-2 from the European Space Agency. If you go commercial, it's 3 meters per pixel. That's not enough to see trees, that's not enough to see restoration sites, that's also not enough to even understand what is going on the site. You really, really need to include communities into the data co-curation. And what we do at GainForest is basically, we have boots on the ground. We have something called Measure to Earn, where we use blockchain-based technology to incentivize data collection on the ground. For every data picture of a tree, for example, we pay 33 cents to communities. we make sure that the value of nature is not just captured by an abstract idea, but actually getting paid in the wallet. So that's where you understand suddenly this tree is actually very valuable when it stands for a community instead of when it's cutting down. So not only are they contributing to the data, making data sets that we collect more equal and fair, but also it's a teaching method. It's a method for upskilling these communities, making sure they get not left behind in the digital economy, but actually get rewarded by collecting that data, by preserving the trees. And so we create this 3-layer, basically drones, satellites, and field-based collection to really then have a holistic picture of what's the impact on the ground for donors, for institutional investments, for partners, to really make better decisions. And we do this not just, again, like Alan said, in 1 year or 2 years. We do this every 5 days with satellite data. We do this every month with on-the-ground data point collection. And so really, we believe one of the things which really hinders all the negotiations that are happening right now here is trust. Trust in that impact is delivered, trust in that payments are given if impact is delivered. And we believe that the only thing negotiators and delegates here can really trust in is you see what you believe in. And if you have this technology stack like Web3 that builds on trust generation, that's something we can really, really leverage and really use to drive urgent climate action.
That's fascinating. I love how you distilled that, broke it down, saying, by leveraging this technology, you can enhance that transparency, that verifiability, seeing through the different layers, breaking down the barriers, and showcasing what the actual impact is to these local communities. To me, in many respects, it seems like it's, a new and very fresh version of older traditional market-based mechanisms, right? The market-based mechanism that is the longest standing, the most generally recognized is the voluntary carbon market, right? Obviously, that has received a lot of attention in recent years, and certainly a lot this week. Thallo is a new player in the voluntary carbon market. Can you talk to us a little bit about how Web3 tech can intersect with the voluntary carbon markets and also with the Paris Agreement to drive some more measurable impact in this space?
Yeah, so I don't know how familiar everyone here is with the voluntary carbon markets. So if I say anything that doesn't sound familiar or you don't know what's going on, just let me know and I'm happy to explain. But the voluntary carbon market has been operating for maybe about 20 years. It's largely based on trust. It's largely based on these sort of centralized entities, the registries or the GHG emissions protocols. And these essentially are the arbiters of truth in the market. And they're the ones that say 1 ton of carbon has been sequestered or avoided in this process. Now, what ends up happening is that the length of time that it takes to get from a project being done on the ground to a carbon credit issued, we actually at Thallo just did a report on this, working directly with carbon project developers to find their experience. It can take anywhere from 1.5 years to 6 years. That, as we were talking about with these delays, is a huge cost not only to the folks who are involved in that project, but also there's a planetary cost. And in fact, we quantified that if the current kind of ability to issue those carbon credits does not scale as much as it needs to, that could mean 4.8 gigatons of carbon that do not get issued of carbon credits, that does not get sequestered by 2030. And that is the same footprint of combined all the people in California. So to get back to this, what we're doing here is essentially trying to make this whole market more transparent. You cannot manage what you do not measure. And I'm going to steal the Washington Post tagline, which is "Democracy dies in darkness." I think that climate action also dies in darkness. And the actors that are sort of entrenched in this market can benefit if nobody is scrutinizing the market. So what we're doing at Thallo is essentially trying to make it very, very clear what is happening in this market. And we're specifically focused on project developers. David talked about, speaking to people on the ground. It's really great to talk about the benefits of blockchain. It's very important also to go back to those communities on the ground, not just the project developers, but even the local indigenous communities that own the land, and have conversations with them about what this technology is and how it can benefit them. Ultimately, what we do is we essentially take these carbon credits, tokenize them, put them on the blockchain, And that's when you get that programmability I mentioned earlier. Specifically, what we're doing is adding an element where royalties go back to the project developer in a situation where a carbon credit doesn't get retired and in fact just gets traded onward. So I think this is sort of what we see as a first step of unlocking some of these intersections between blockchain technology and the voluntary carbon markets. In terms of the Paris Agreement and the next steps there, there's of course a lot that remains to be solved and remains to be clarified around Article 6.2, Article 6.4. What I think is really exciting and inspiring in this moment is that programmability means that once we get clarity on those elements, that is something that we will have the data on chain for, and we can start to actually adapt and make sure that corresponding adjustments are happening, et cetera. So I think that this is the work that we're all doing now is sort of foundational to the next step in the carbon markets. And really will be instrumental to scaling them and also to evolving them so that they are better fit for purpose.
Yeah, that's wonderful. And what really sticks out to me there is the simple word of complexity, right? Martine talked about it from an international policy perspective, David from a community-based project perspective, you from a market-based, specifically from the VCM perspective. That involves a tremendous amount of stakeholder management, right? In all these complex interactions across these different silos. Ori, amongst your many skills, one of the things that you do is manage a lot of our external stakeholder management tasks, right? You lead our grants, you lead our hackathons. We have seen throughout that work that Web3 and specifically the Web3 communities can come together and be a real force multiplier. So can you talk to us a little bit about your experience and your perspective from working with various communities, specifically in the Web3 space, to actually drive adoption and scale of these solutions?
Yeah, so we recently launched our $1 million regenerative finance grants round, and in collaboration with a lot of the other Web3 companies, we really want to focus on refi. Refi, for those who don't know, is a new way I look at the economy and really looking at the nature-based sort of credits, the nature-based things that we have, and how can we regenerate them, and how can we focus on them, this new sort of way of thinking about the economy. And so looking at sort of our refi projects, we were able to really help support grantees such as GainForest, such as helping look at traceability at the forest in Suriname, and then rewarding e-credit tokens for waste management in Brazil. So we really are able to support projects in both the global north and global south in really reshaping how they look at sort of climate change and finance in their industry. So I think that it is a really big push, and as all of the other panelists have said, that you really have to go in the local communities. And so we do want to be the aggregate. We do want to support these projects that are working in these local communities and really do know what they need.
That's fascinating and so critically important, right? To work with these people on the ground, to understand their needs, their pain points, their perspectives, and to develop solutions in a bottom-up fashion that actually bring that value back to them. David, I want to kick it back to you on this exact point, right? You guys have been on the ground in various countries around the world, driving some pilot projects, starting to scale your application. Talk to us more about that, right? Let's peel back another layer of the onion and talk, what's happening, what's been happening, where are you guys going from here?
Right. So one of the things we really understood is, first of all, we thought we would come with them with a solution to support. And when you work with local communities, one of the first things you're going to realize is going to be like, you actually learn way more from them than they learn from us, right? So you understand, first of all, what are the priorities. You need to you understand the value of co-designing solutions together, because if you're not designing solutions with the communities on the ground, no one's going to use your solution. And also one of the things I understood is one of the reasons we fail to value nature is because we are very disconnected from nature in the global north, while the communities in the global south and the ones in the indigenous communities, they are nature. So every time I make this small experiment and let people close their eyes and imagine nature, in the global north, they see forests, they see trees and mountains, but they don't see people. And it's very, very different in the global south, where they see communities, where they see people And the disconnection is one of the reasons why we believe the valuation of nature is missing and lacking. So what we try to do is basically using data, we're trying to rebuild this bridge of connection to nature. We use this with multiple blockchain-based technology ideas. One is NFT. So we let communities collect this data, as said before, using pictures of like trees and pictures of also wildlife, animal and captures, and we put that as an NFT, as a reward for a donor, immediately on your phone. And that is now a tradable asset. That is something that reminds you that you have invested in this area, in this project, and it also connects immediately with the data. You see it on your phone. You don't have to visit a website. It's next to your wallet, next to where your money is stored in Web3. And we believe that building this bridge between data, nature, and money, we can appreciate the valuation of nature itself and rebuild basically this deep connection which we are lacking right now in the global north. And communities are essential for this because they are the ones that collect the data. You have to understand when you look at a tree picture, it's not if I look at mangrove picture right now, for example, in the Philippines, we've been collecting 20,000 trees and mangroves. We pay them, again, 33 cents per picture. If I look at a picture of a mangrove taken, this is not a picture, this is not math, these are not numbers. This is a human story. This is someone who took 7 hours, for example, to get to this mangrove, sometimes have to wait for a certain time of the day in order to enter this mangrove, because otherwise there's like flooding, there are crocodiles, you kind of collect it. And then while they're taking these pictures, they're probably getting bitten by mosquitoes thousands of times per day, right? So you really have to originate and understand that data is human, data is nature, nature is data, and we need to make sure that also people who collect that are appreciated and are getting paid. And that's what our system is trying to do. And using blockchain technology, you can see every single payment that is provided from your donor account to a single community, to a single person who has collected this data. And that's why we think this is very, very powerful, because we are, for the first time in humanity, have something we call end-to-end transparency from your wallet as a donor in the global north to the person who actually collected this data point. And we think this is super powerful for connecting us.
Ah, that's wonderful. And I want to surface one of those words you mentioned a few times, the disconnection that exists, right, in many states of these projects today. And it reminds me of something Martin said in some of your opening remarks, right, about how this technology can be used to enhance the visibility of the value and the impact that's being accrued. So I want to ask, do you have any remarks to add about, Martin specifically, about how approaches like what GainForest is employing now could help you at Open Earth Foundation realize the goal of a more comprehensive and more timely global stocktake as it relates to Paris?
Yeah, I mean, in regards to the global stocktake, there's a couple of things around transparency and visibility. Building on like the voluntary carbon market and verifying projects on the ground, that also needs to be visible for, we have greenhouse gas inventories and we normally have land-based sources and sinks inventories. These really need to talk to each other, often do not. So the other thing is visibility across registries. So that's why to be able to have clarity on corresponding adjustments or international transfer mitigation outcome, we need to be able to create that level of spatial visibility. How can we do in the future, or not so distant future, spatial queries within a jurisdiction and understand within that area projects that are active, data that we have about the stocks, the natural stocks there, mitigations that originated there, even if they're all in different databases or registries. That's key. One of the things that I would also like to add, I love what you said about like in the global south and particularly in the communities, we have to sort of like learn and remember that we are part of nature. One of the key things about visibility and transparency is actually using that to embed nature in all of its intrinsic value into our economic system. And we believe now more and more at the Open Earth Foundation that we need to bring it inside the monetary system. Pre-Bretton Woods, we have gold as the reserve asset, and in many central banks and treasuries, there's still like billions and $1 trillion of gold bullions doing absolutely nothing, but feeding into the narrative of something that we've agreed that has value. we can change our agreement of value. And one of the things that we can learn from communities that have always known that is that, and bring it into our paradigm. So we've had a very interesting process because we started working on the global stock ticket, and that's probably 50% of our work on like understanding and envisioning a digitally enabled independent global stock ticket that includes non-state actors and the infrastructure for that, which is why yesterday or 2 days ago, we launched the Open Climate Network. You can go to the desktop version, openclimate.network. But then we started working on oceans, which are most of the time totally forgotten. It's 70% of our planet. We barely have ecological credits for oceans. They're not included in natural capital accounting, which is, for example, the UN system of environmental accounting. And we barely have good financial mechanisms to fund marine protected areas. Because oceans are so complicated, because there's so much uncertainty and the ways of financing it, and because it's all like either economic exclusive zones or the high seas, there's no role for like the private sector to really play a role. We really had to think out of the box. And that led us to really think, how can these massive natural capital stocks actually become the reserve asset of sovereign currencies or bioregional currencies, because nature knows no political boundaries. So we are in an exciting process of working with a lot of different collaborators to rethink, how do we launch a multi-year research and digital infrastructure project so that we can collaborate with central banks, with private banks, and with, let's say, the independent Web3 community to really know how we do this and how we do it right, bringing all the right stakeholders involved. Because we don't get to do that multiple times. We have sort of like got to a point where we can do nature or money 2.0 once, because if we get it wrong, there's no room for, there's no margin of error. So this is where a lot of these tools that we talked about here, we believe can converge, and through our new stories, through our collaboration, we need to get to a point where if we have the right incentives, programmable money, which is also what Web3 brings, is designed to support climate action and natural conservation. Because if you don't, then as the natural capital collapses, so does the currency. If you do, then so does the financial capital wealth.
Yeah, absolutely fascinating. So spot on. And in staying with that ocean theme, what I think you've just explained is that even with all the topics that we've already discussed in the last 25, 30 minutes, we're only touching the tip of the iceberg. There is so much to unpack here, and there's so many opportunities for this tech to be utilized to drive measurable impact in so many regards. In respect to timing, I want to wrap us up, but I want to give the panel some time for closing remarks. Is there anything that hasn't been said that needs to be said, or anything that's top of mind? Hayley?
I always have a comment. So what I want to say is that, so I've worked in this space for 15 years. I'm certain there are people here who have worked in this space longer, but a couple of observations from me, and specifically reasons to be optimistic. I have seen people coming into sustainability and climate tech who have backgrounds in literally everything in the last 18 months or 2 years. It's people from finance backgrounds, it's people from software backgrounds, it's people who got into crypto in 2012 and basically have been in crypto the whole time and now are interested in moving into climate tech. And I think this is really, really good news. I think it is really exciting that I have friends who are working in totally different sectors and they know what COP27 is. That didn't used to be the case. It is really, really exciting. And what I would offer is that, particularly in the Web3 space, there also needs to be that same kind of influx of people engaging with it. So like I mentioned, I come from outside this space. It can be very intimidating because you hear the word blockchain, and sometimes before you kind of dive into that, you want to just kind of shut your brain off and be like, who can I talk to that's not a blockchain person, But I would encourage, I think that in order for these tools to be best leveraged, we need people who are thinking about all these different components, all these different stakeholders, all of the different parts of the equation to get where we need to go. It's government, it's civil society, it's businesses. So I think not only do we need everybody focused on climate, because we need everybody's big brains there, but also we need a lot of folks to be engaging in these Web3 tools and understanding how to wield them. So I'm super optimistic by this change that I see, and I'm really glad that that's the direction we're headed. We've got to move quickly. We have a lot of urgency in front of us, but I think we're headed in a good direction.
Wonderful. That's amazing. Any other comments, or should we leave it there?
I have hope that as we think of designing those digital highways that I was alluding to, or the way that we've talked about it as the operating system for Spaceship Earth, it helps us come back to the consciousness that was just mentioned, which is that we are Earth. We are not separate from it. We're not separate from nature. If we do that, we're able to realize that we're really all in this together. There's a lot of room for competition between startups, between institutions. That makes a lot of sense. But there is the common layer that connects us all, which is we're all stakeholders, we're all part of this planet. So I actually really see, ironically, digital infrastructure and technology would also feels like disconnects us from nature. We also see like people connected in their phones or like living in the metaverse. That actually might be bring the ability for us to realize that we're part of it. It has to happen through radical collaboration, through open source. That's my one hope for humanity in the next couple of years.
No, that's beautiful, and that's perfect ending right there. Thank you all for these great comments, for joining us here. Thank you once again to the UNFCCC for having us here, and thank you all for being here and participating.